Hello and welcome, and in this video we are going to be solving exponential equations. Now, when we're talking about solving exponential equations, there's generally two major methods that we use to solve them. And today we're going to be taking a look at that very first method, which is to use something called the one-to-one property. I'm going to explain exactly how to do this throughout an example, and I'll also kind of explain to you what the one-to-one property is, because I'm assuming you might be wondering, well, what the heck is that? So let's go ahead and take a look at an example, such as this one. We have 36 to the x plus 1 power is equal to 6 to the x plus 6 power. Now, this is an exponential equation because, well, it's an equation, and on one of the sides, there is an exponential expression. Well, in this case, there's an exponential expression on both sides, but generally, if there's at least one exponential expression and it's an equation, we generally call it an exponential equation. So, in this particular example, we are going to use the one-to-one property, and that is because we can actually rewrite each side with the same base. What I mean by that is that 36 is 6 to the second power. That would have a base of 6. And on the right side, we have 6, which is just like 6 to the first power, which also has a base of 6. Now, if we're able to rewrite each side with the same base, this is generally the easiest way to go. We're not always going to be able to do that, but if we're able to, let's go ahead and work on that. So I would be able to rewrite each side with the exact same base. So notice here I have 6 to the second raised to the x plus 1 power. I'm not actually changing the number 36. Notice 6 squared is 36, so I'm not actually changing this number at all. That's 36, and that 36 was raised to the x plus 1 power, so I'm showing that. And on the right side, I already actually have a base of 6. So notice I have a base of 6 here, a base of 6 here, so that step is done. From there, we need to use the properties of exponents if necessary. Now in this problem, we have a power raised to a power. I have 6 squared raised to the x plus 1 power. So in this problem, the property we need to use is the power rule. When you have a power raised to a power, you multiply those powers. And I'm actually only going to need to do it on the left side of the equation. Notice the right side, I don't need to use any properties. It's already just a simple exponential expression. But on the right side, I need to multiply those two powers like so. So I go ahead, and this is really important. Notice I distributed that 2 to the x and the 1 to get 2x plus 2. That's very important. We need to make sure that when we have a power raised to a power that we're distributing it throughout. Okay, so that 2 distributed to the x plus 1. Now, once we use all of our properties, and in some problems, we're going to have to use some other ones. Maybe we'll cover some more challenging examples a little bit later. But for now, let's just kind of work on it here. From here, what we would do is now we would use the one-to-one property. Now, once again, you might be going, well, what is the one-to-one property? Well, it's actually quite simple. Basically, if you have an equation, and on each side of that equation, you have the same base. So in this problem, we have 6 to the 2x plus 2 power is equal to 6 to the x plus 6 power. The bases are the same. What that means is that the exponents must be equal. That's all the one-to-one property is, and this is the one-to-one property of exponential expressions. So what we can do here, since we have an exponential expression on each side of the equation, just one of them, and they have the exact same base, I can now set the exponents equal to one another, like so. Boom. 2x plus 2 must be equal to x plus 6. And that is because we had a single exponential expression on each side of the equation, and they both had the exact same base. Now, we're going to cover some problems where there's going to be more than one exponential expression on each side. We'll talk about what to do when we get there. But here we can go ahead and use the one-to-one property to set the exponents equal to one another, and then we can just solve using all the methods that we've done up to this point. This is just a linear equation, so we just have to basically get the x's on one side, everything else on the other side, isolate x. If this was like a quadratic, we could try solving by factoring or something along those lines. And that gets us an answer of x equals 4. I can go ahead and subtract x from each side, subtract 2 from each side to get x equals 4. And if you want, you can go ahead and plug in 4 for x into both sides of the equation, and you would notice that both sides actually get you the exact same number. And that's really it. that's solving exponential equations using the one-to-one property. Now, I want to take a look at a couple of more problems just to make sure we're all on the same page. They're going to start getting a little bit trickier, okay? For this next example, I'm going to keep the steps up so we can kind of refer to them, and then we're going to start getting away from actually having the steps written in front of us. So let's go ahead and take a look at another problem. So let's take a look at this one. We have 4 to the 4x plus 7 power is equal to 16 to the x plus 3 power. Well, my first step is to always try to rewrite each side with the same base if I can. And in this problem, we can. The left side has a base of 4, the right side has a base of 16. Well, I can rewrite 16 as 4 to the second power. So that's exactly what I am going to do. I'm going to go ahead and rewrite each side with the exact same base. I don't need to change the left side, although you technically could. You can make 4 2 to the second, base of 2, and then you can make 16 2 to the fourth, base of 2, and then solve from there. So you can kind of use different bases in certain problems. But here the easiest one would be 4, right? Because that way I don't need to change the left side at all. The right side, I'm just making 16 4 squared. Notice I'm not changing the number. 16 is 4 squared, so 4 squared gets us 16. 16 was raised to the x plus 3 power. So I'm not actually changing anything in the problem. I'm just rewriting it with a different base. From there, I can go ahead and use the power property once again. I had 4 squared raised to the x plus 3 power. And once again, notice when I have a power raised to a power, I got to distribute that power. So 2 times x gets me 2x, 2 times 3 gets me 6. So that becomes 4 to the 2x plus 6 power. From there, I can go ahead and see that I have one exponential expression on each side. They both have the same base. That means I can use the one-to-one property. So let me go ahead and set the exponents equal to one another. There we go. I can now say with certainty that 4x plus 7 is equal to 2x plus 6. And now we can go ahead and solve. So I can go ahead and subtract 2x from each side, subtract 7 from each side to get 2x is equal to -1, and then divide by 2 to get x equals -1. And once again, you can go ahead and you can plug in -1/2. Did I say -1? -1/2 in for x on both sides, and you would get them equal to one another. Okay, now I want to cover some ones that might be a little bit trickier, and we're going to get rid of the steps. All right, so let's take a look at this one. We have 9 raised to the x plus 1 power is equal to 27 raised to the 2x minus 5 power. Now here, we're going to try to rewrite each side with the same base. Now, a common mistake I see is seeing people write 27 as 9 to the third power, but you're getting confused. 9 to the third power is actually, like 729? You're thinking 9 times 3, okay? So we can't use a base of 9 here. It doesn't work. What we could do, though, is use a base of 3, because 9 is 3 squared, and 27 is 3 cubed. So I can rewrite each side with a base of 3. So I'm going to go ahead and rewrite 9 as 3 squared. I'm going to raise that. So this is 9. 3 squared is 9, and 9 was raised to the x plus 1 power. So there I go. I have 9 raised to the x plus 1 power. I didn't change anything. And then 27 is 3 cubed, so 3 cubed. And 27 was raised to the 2x minus 5 power. Notice I didn't change anything. This is still just 27. I didn't change the number. And that number was raised to 2x minus 5 power. I didn't change the power. Okay, we're just rewriting it with a new base. And now here is when we go ahead and we use some properties of exponents, if we need to. And in this case, we definitely need to, because we have powers raised to powers all over the place. So now I got to go ahead and distribute the power. So on this left-hand side, I'm going to have 3 to the, well, that's going to become 2x plus 2, because I'm distributing the 2 to x and to 1. So I get 3 to the 2x plus 2. And on the right-hand side, I have 3 to the third raised to the 2x minus 5. So I got to distribute that 3 to the 2x, which gets me 6x, and 3 to the -5, which gets me -15. And now, well, hey, this is the one-to-one property. I have a base of 3 on the left side, got a base of 3 on the right side. I can set the exponents equal to one another. That's all that the one-to-one property is. So now I can go ahead and say, hey, 2x plus 2 must be equal to 6x minus 15. And now I can go ahead and solve this because, maybe this is from algebra 1. We can do this. All right, so I'm going to go ahead. I'm going to subtract 2x from each side to get 2 is equal to 4x minus 15. I'm going to go ahead and add 15 each side to get 17 is equal to 4x. Let me go ahead and finish up here. I'm going to rewrite that actually. 17 is equal to 4x. And now all I got to do is divide by 4 and I'm done. So x is equal to 17 over 4. If you want, you can write that as 4.25. I get it. Some of you don't like fractions. I don't know why. But you can leave that as 17 over 4. I would not mind in the slightest. And that would end up being our final answer. Now I want to go over one more. Just one. And this one's actually going to be a little bit trickier because it's going to involve a little bit more work for the properties part. Okay, so let's go ahead and take a look at our very last problem. All right, this one looks crazy, right? We have 4 to the 2x power times, we haven't covered that. Well, we're going to. Times 2 to the 3x minus 2 power is equal to 8 to the 4x plus 1 power. Nothing changes here. We're going to try to rewrite everything in the exact same base. I have a base of 4 here, I have a base of 2 here, I have a base of 8 here. Those could all be rewritten with the same base, and that base would be 2. Because 4 is 2 squared. Whoops, I don't want to write that. 4 is 2 squared. 2 is 2 to the first. And 8 is 2 to the third. So I can use a base of 2 here. So I'm going to go ahead and do that. So 4 is 2 squared. And that 4 was raised to the 2x power times. Oh no, times. It's not that big of a deal, guys. Promise. Times 2 to the 3x minus 2. That already has a base of 2, notice. So I don't want to change anything there. And then that equals, well, 8 is 2 cubed. And 8, this is 8 once again. I didn't change it. That 8 was raised to the 4x plus 1 power. Okay? And now I'm going to start using properties. It's just that we're going to have to use one extra one. Don't freak out. It's literally one extra property. But first, I'm going to go ahead and distribute my powers. So this is going to be 2. Well, this was 2 raised to the 2x power, so that's going to become 4x. We multiply the exponents times. This one I don't have to change anything yet. Is equal to, well, here I had 8 raised to the 4x plus 1 power, so now I have to distribute that 3 to everything. So it's going to be 2 raised to the, 12x plus 3 power. Now, I can't use the one-to-one property yet because I don't have a single exponential expression on the left-hand side. I need to do that. Notice they have the same base and they're multiplying one another. Well, think back. You've done this like over and over again. If you had x squared times x cubed, you probably would have, without even guessing, added the exponents. That's because they have the same base of x. Well, if I had 2 to the second times 2 to the third, the exact same thing occurs. They have the same base of 2, so I'll just add the exponents to get 2 to the fifth. Hey, look at there. They have a base of 2. I can add the exponents, okay? So what this is going to become is 2 to the, and I'll actually write out all of this work, 2 to the 4x plus 3x minus 2 power is equal 2 to the 12x plus 3 power. Notice that when you have like bases multiplying, all you're doing is you're adding the exponents. I'm just adding the exponents there. There's no big deal. And now I can go ahead and use the one-to-one property. Let me go ahead and erase this real quick so I have a little bit more room to work with. All right, and now I can use the one-to-one property because I have a single exponential expression with a base of 2 on the left. I have a single exponential expression, words are hard, right, on the right with a base of 2. So now I can set the exponents equal to one another. So I can do 4x plus 3x minus 2 is equal to 12x plus 3. And once again, now we're just dealing with algebra 1. This is so basic. Now we just got to go ahead and solve for x. So the first thing I would do is I would combine like terms to get 7x minus 2 is equal to 12x plus 3. And now I can get x's on one side, everything else on the other side. So I would subtract, personally I would subtract 7x from each side to get negative 2 is equal to 5x plus 3. I would then subtract 3 from each side to get negative 5 is equal to 5x. And then I would divide by 5 to get, look at that, that worked out so nice, x equals negative 1. And that would end up being our final answer. And that is really kind of as complicated as they get. They don't get too much crazier from here. Just make sure you are aware of all your general properties of exponents. They might come in a little bit handy here. And this is kind of part 1 of solving exponential equations, because in this one, we were able to use the one-to-one property. We were able to write everything in the same base. In the next video, we're not going to be able to do that. So we're going to learn how to do that in the very next video. But I hope this one was helpful. If there's any questions, please feel free to reach out and let me know. Otherwise, I look forward to seeing you guys in the next video.